Hey there, Mr. Leatherwood.
And Mrs. Weeks.
And this week we're talking about comparing fractions.
Woohoo.
We've already done a video on least common multiple.
Right, which hopefully will help them when they're comparing fractions.
Definitely. And we have 4 or 5 different strategies we're going to do with this, so don't get confused with them all. Hopefully we'll make them nice and easy for you.
And we'll go pretty fast.
Pretty fast. So the first thing I want to do was comparing fractions using models.
Okay. So you're going to be drawing some stuff.
Yeah, so we'll do 3/4 compared to 2/8.
Yeah.
Would be fine. Start off with an easy one.
You just don't want to draw 16ths.
That's very true. And the way I do my models, I try to keep them the same size. I know a lot of people like circle models. I'm not a big fan of that. I like using rectangles because it's easier for me to cut them up. And when I compare them, so right here I'm creating 2 different models. It's easier for me. They don't have to do it this way, but that's how I do it. So I know right here I'm cutting one of my models into 4ths, and I know I'm cutting the other model into 8ths. So I'm going to cut one of my models into 4ths, the best I can.
Okay.
And then I'm going to do one of my models into 8ths. I know 4ths cut into 2 parts are going to be 8ths.
Do you?
I do. So there's my model. So my model for 4ths is here, my model for 8ths is here.
Right.
And then I'm just going to color in what I have. So I have 3/4.
We always appreciate the music.
Yeah. And I have 2/8. And so looking at this, I can tell this is much bigger than this here. So I would just say 3/4 is greater than 2/8.
And in terms of math, a lot of the kids see the relationship between 4ths and 8ths already and know that when we were doing equivalent fractions that 2/8 is equal to 1/4. So that's, so
Yeah.
anyway.
So models are important to me.
Absolutely.
Okay.
Absolutely.
Let's look at something else. Matching denominators.
Ooh.
So that means the bottom number is the same.
Right.
So any number with matching denominators.
Exactly. And these are easier because this is just a 1-to-1. We're just looking at the pizzas cut in the same, with the same number, and then all we have to compare really is the numerator. So,
Kind of like what we talked about with least common multiple. on our
exactly. Is that's what you're aiming for because it's much easier to look at it?
video. So we can pick any number. And it's nice. They're both 24ths. If I was to draw a model, they both look exactly the same. And then we just have to look at the top number, the numerator.
Exactly.
And so 16 is clearly bigger than 8. So your
Right.
answer is going to be just like that.
Yep.
And if you use least common multiple and you turn your whatever fraction you get, let's say you got 3/4 and 11/16. If you will change these bottom numbers using least common multiples to be the same, it's much easier to compare them. For instance, I'm going to do this quickly. This is going to stay the same. And this one is going to be 12/16.
Right.
Okay, because I multiplied by 1, multiplied by 1 on the top. Over here, I multiplied by 4, multiplied by 4.
And this would be after you had done your little
Least
chart
common
knowing
multiple.
to figure out that
Yes.
16 was the least common multiple between 4 and 16.
Right. So I took a shortcut, but yes,
Right.
you want to do that least common multiple
Yes.
step.
Yes.
So I know that 12/16 is 1 larger than 11/16. So using least common multiple, I figured out that 12/16 is greater than 11/16.
Right. Sure does make it easier when those denominators match.
It really does. All right, next one.
Here we go.
Matching numerators.
Now, does this really help you at all?
Well, we'll see.
Okay.
So matching numerators. So the top number is the same.
Right.
So let's say we had 3/9 compared to 3/20.
Okay.
Okay, so you explain this one. No, maybe?
No, that's
Okay,
great.
okay.
I'll tell you the way that I always tell the kids. Look at it from a 1/9 perspective and a 1/20. What do you know about ninths versus 20ths? And you should know that a ninth is bigger than a 20th.
Right, it's going to be a bigger piece of the pie.
Exactly. So no matter what, if you have 3 of those ninths, that's going to be bigger than 3 of those 20ths because you already know the 20th is smaller than the 9th.
Okay.
So that's comparing it 1 to 1 and knowing that the number on the top is the same. So therefore, if it was 1/9 and 1/20th, you know that 1/9 is going to be bigger. If it's 2/9 and 2/20ths, you know that 2/9 is going to be bigger, and 3/9 and 3/20ths. So
Okay.
that's where those matching numerators can help, but you still need to be looking at the denominator. So
Okay.
you're going to draw something.
I
aren't
am.
you?
Just so they can visualize what you're talking about. So, is that okay? I think it's
Not
important.
really.
No?
I'm highly insulted.
So, for instance, that
All
would
my
be.
kiddos out there are going, we know exactly what
I
Mrs. Weeks
know.
is saying.
So there's ninths,
You're right,
right?
ninth. Uh-huh.
Okay, I'm going to try to do 3, 4, so that would be fifths.
Mm-hmm.
And if we do 4 times 5,
There's your 20ths.
those would be 20ths. So we can see if we color in one of these.
Mm-hmm.
So this is 1/9,
Mm-hmm.
and this is 1/20th. So you're saying that the 9th is bigger.
Right,
Then
absolutely.
the
Because if
small.
you ask any kid, I'm going to give you 1/9 of a candy bar or 1/20th of a candy bar, they're
want
going to
this
want,
one.
yes,
I
they're going to
want
want the bigger piece of it. So
Okay.
that's going to be bigger. So already if you know one of those is bigger, you know 2 is going to be bigger. You want to color him in. You're
Oh.
going to stop coloring?
Oh, no, I can color more.
Okay.
So we could color in the 3, you mean?
Yeah.
And then over here we color in the 3.
Mm-hmm. Because you wanted them to have that
Yeah,
visual.
I do. I want
Yes.
this candy bar, not this
Versus the-
candy bar.
Exactly. So you're still trying to look at those denominators, but because it's a 1-to-1, the relationship is the same on the top. You know that you can look at those denominators and tell those pieces of those 9s are going to be bigger than the pieces of the 20ths. So
Groovy.
groovy it is.
Yes, it is. Benchmarks. I love benchmarks.
I know you do.
I do. I think it's a great tool. And when I talk about benchmarks, I usually use a number line.
Oh, yeah.
It's helpful to me. And we'll use a simple one, 0 and 1.
Oh, what a good one.
And benchmarks, for those of you that don't know, are things that you can easily find.
Right.
Like on a number line, for instance, I can easily find 0 and 1.
Right.
I can also easily, for me, find
half.
1/2.
Yeah.
Okay. That should be easy for most of us now.
Exactly.
Okay, and I would almost argue we could probably do 1/4 and 3/4, but we'll go ahead and stick with
Exactly.
0, 1/2, and 1. So these are your benchmarks: 0, 1/2, and 1.
There's a fly.
There is a fly. Miss Weeks is dancing from
Don't
this
like the fly.
vicious fly.
It is vicious. I think it had teeth.
So what we can do here is we can start to compare fractions using our benchmarks.
Right.
So let's say we had 2/5.
Okay.
Okay, kind of a tricky one.
All right.
So if we wanted to know where to put this on the number line, we can try to see, is it closer to 0, is it closer to 1/2, or greater or less than 1/2, or closer to 1. Okay, so I know 1,
It'll be 5/5.
5/5.
All right.
I know 0, hopefully we know, is 0/5.
Exactly. That's way down there.
Yeah, and if we do half of 5's kind of a fraction or a
Right.
decimal, but we should be pretty good. 2.5
Right.
over 5. Right, not something we
So
traditionally
it'd be a
would do.
little bit more than 2. You'd have to know that.
Right.
Yes.
So if we're looking at our 2/5, we know that it's a little bit less than this. It's definitely not close to 0.
Right.
So if anything, if we were kind of estimating, we'd put it, I don't know,
Live close
Ish.
to half.
okay,
Yes.
closer to half than 0.
Right.
So that helps us there. And if we were comparing another number, let's say we were comparing it to, I don't know, 4/6, would be fine. We could do the same thing. So 6/6 would be over here. We know 0/6 is here.
And
then
hopefully they know that the half would be 3/6.
3/6. And since our number's 4/6, kind of the same thing. It's a little larger this time than half. So we could say, I don't know, let's put it here. So this was 2/5. So then we could say, okay, 2/5 is a little bit less than 4/6.
Exactly.
So we can use those benchmarks to kind of place on a number line.
And I like the number line.
Yeah, we'll do that this week. We'll do an activity where they it's kind of taped out on the floor, and they can practice putting things on a number line.
Absolutely.
So it'll be good. All right,
Perfect.
we've got one more thing, I think.
Okay, yeah.
All right. Bigger or smaller parts?
Okay.
We kind of did this one already. No? Didn't we?
I thought we did. You mean with the drawing the little picture, you think?
Yeah,
I think you did.
kind of so. It's kind of the same thing, kind of determining how far away from it.
Right, the distance away. So you would take what was left,
Right.
I always say. So like if it was 7/8, you have 1/8 left to make it. So comparing those, almost what's left.
Okay. So let's say we
Yeah,
were
there you
doing
go.
7/8 and we were doing 8
about-
ninths.
Okay,
Is that okay?
yeah.
I think that kind of shows us.
Okay, that's
So
perfect.
kind of what you were talking about earlier,
Mhm.
the smaller denominator is going to give us a bigger piece,
Right,
and a larger one is going to give us a smaller
Mhm.
piece. So in this case, we have 7/8, so the
Mhm.
kind of larger pieces,
mm-hmm,
and we have 8 ninths, the smaller pieces. So
yes.
you're kind of trying to determine how far they are from a whole.
Yes, exactly. So if you were running a race and you were trying to get to that finish line, who's closer to that finish line? Who has less to go, less distance to go?
Well, this
And
is
that's going to tell you what the bigger fraction is going to be, because whoever has the smaller amount to go, would be the bigger amount
all right.
fraction.
So since ninths would be smaller, they're almost there. They've got
Right.
the least
They have
amount of
1/9
distance.
left to go, whereas the 7/8 has 1/8 left to go, and we should know that 1/8 is bigger than 1/9. So the 8/9 is larger.
Okay. There you go.
This all makes perfect sense to all of us.
Yeah. Do you want me to draw a picture?
I think you want to.
I do.
So I'm not going to deny you.
Okay. And try to note my pictures, I try to make them roughly the same size so we're comparing. Right? Ish. They're kind of the same. Alright, so I'm going to do ninths again.
Mm-hmm.
Tic-tac-toe. And then I'm going to do eighths.
Mm-hmm.
So you can see the eighths are a little bit bigger.
Mm-hmm.
Right? A little bit bigger than the ninths. So that tells us, like you said earlier, that they're going to be closer to finishing. So
Right.
Right, a little bit bigger.
Yes.
All right. That's all we got.
Awesome. That's
So
all we got.
a bunch of strategies.
Yes, exactly.
The
But we'll
key-
use them all. We'll practice them
Right.
next week. So.
And the key here is once you practice all these, determining what's easiest for you.
Exactly.
Like for me, I like the numbers. I like finding least common multiple and just changing my denominator, numerator, and doing it that way. A lot of you will like the pictures, drawing a model. So you just have to determine what's good for you.
Exactly.
All right. Bye-bye.
Bye.